Welcome everyone. It has been some days and as I'm currently not in the office, the quality is not up to my usual standards, so if this is too bad then probably have to redo it again and get some other PC. Anyway, continuing with this ultra low voltage stuff. Imagination from previous 25th anniversary, one of those early innovators of 3D hardware isolated graphics, and as the first silicon wasn't the very high performance, they later went into mobile and worked into the mobile space, also supplying all the previous generation iPhones with the IP. And they recently had their 25th anniversary, and not even a year ago, just a little bit more than 6 months ago, dreaming of getting back to a high performance game. I question that a little bit, but we will see. And because there's last October was 20 years, something. Imagination Tech and they want to get back to high performance gaming and cloud and desktop and stuff. We will see if that will ever come to fruition. But 25th anniversary, how did they start? They started with an FPGA board, as so often, PCX2 and PCX3, PCX and PCX2, and then Neo 250 and Kuro. Previous video, right, we sold out there some DVI, and also they also later supplied Intel's GMA 500 and 3000 or so. This is PowerVR. And what is the big difference? Why do we even talk about this? They have a different hardware rendering strategy. By the way, if you're live to this channel, you could leave me how bad the video and audio is today, as we have usually higher standards here. But so PCX1, and what they have different than Voodoo and then NVIDIA and ATI and even Matrox and all the others in the game is all the others are immediate mode renderer. I made a couple of videos. We programmed this on the S3 Verge, on the Voodoo, on the Imagination 128 Revolution 3D, Lynx 3D, and even reverse engineered parts of the Matrox Pahelia. And the difference is that, I also have that here somewhere, so all the other cards render this immediately. You can watch those videos. This means you program them with programmed I/O, with memory mapped I/O, with ring buffers, and the cards immediately render this. And of course, you using the SDK, you don't, like OpenGL or Vulkan and stuff, you don't see that. But behind the scene, the commands are issued, like texture, triangle, and the card does it. And the PowerVR established, or was one of those innovators of doing tile-based deferred rendering. And for a long time I was wondering, what does it even precisely do? Sure, it is in the name. It's tile-based, means it is splitting or partitioning the rendering area into tiles, and that is not even the big thing. So you could do this also with other immediate mode renderers, but the tricky part is in this deferred rendering. And recently I started to take a closer look, because they also, among their 25th anniversary, they actually became big with, or their biggest success, they were never that successful except now partially in mobile, but their big initial success somewhere is the Sega Dreamcast, which is also probably why they had less success in desktop, because initially after the PCX 1 and 2 they won this contract with Sega and had to put all the development resources there, so that their desktop part was delayed, and when it came late to market it was already too slow and too little and so on. And probably this is why they didn't have the funding and stuff to continue with it. So I was thinking, as this I have theoretically my to-do point of finally fully reverse engineering that. PowerVR, it was once upon a time a GNU priority project, but now, you know, GNU priority projects, they do nothing except putting out some words. So I have not seen anything, and all the pages that once existed are deleted. But what I usually like to do, also in my previous videos, Verge Voodoo, look at the basics and see where it all began and derive knowledge and base code on that. And usually the companies, they cannot redo everything from scratch every few years. So usually they just iterate, like Intel's TikTok, every year a little bit better. So usually even looking at the very oldest stuff, you usually learn a lot. Also to work with newer silicon. And so looking at that, here is a Dreamcast emulator, and here's this tile accelerator. So the difference is in where the magic happens. Actually, I would also say magic is maybe it is also a little bit overhyped, and mostly it's like performance or energy efficiency advantage. Maybe it's like it's just slow and not that much advantage. But anyway, so how does tiling work? And I was always wondering how should this work, because deferred, what that means is it's not rendering this immediately as the name implies, but deferring that. And I always wondered how should that precisely work. And I started to look a little bit into the details here, and it's much simpler than I thought. So first of all, we have here Dreamcast emulator code. So here already the parameters, tile accelerator, parameter end of list, object set, poly, sprite, vertex, parameter stuff. And because what is the thing with PowerVR? They never published register level specification, which is also why there are no Linux drivers, right? Super annoying, especially for the once upon a time with Intel GMA 500 stuff. And how this works in lack of documentation, you can see of people here implementing the source code. And if you want to play along at home, you can read that. They go here through these parameters. But to explain that better than just reading the source code is, on a immediate mode renderer, the triangles are rasterized edge walking. So that means walking the edges of the triangle and computing the value, flat, shaded, and textured, and of course nowadays with all the tessellation and shaders. And the difference is, so first of all, the PowerVR is rendering tiles, but that is not even the big thing. But what this allows is to, or what this, I wouldn't even say this allows it for, but so internally, each tile actually mostly nearly works like an immediate mode renderer. The big difference is that the PowerVR does not have a set buffer. Usually all the other immediate mode renderers, they have a set buffer. And in the PowerVR, it appears to be internal. So it appears to be like you can think about this like a level 1 cache on an x86 or other CPUs. So it has a set buffer, and that is the one advantage. You don't need megabytes of set buffer because you only have a level 1 cache, very fast internal. Also, it saves memory. It also saves memory bandwidth. And additionally, so the rendering in the tile is actually, it works nearly like in a normal immediate mode renderer, except as far as I understand this from some nights of going through public documentation and emulator source code, it's rendering each tile twice. First, it is going through the geometry data and it's rendering the set buffer just normally, or only storing set buffer data. And then it's doing a second pass and it's only doing the same thing. Like first it's walking all the geometry just for the set buffer internally in the like level 1 cache. And in the second path, it is then rendering the deferred rendering of the visible geometry, which means set buffer value either equal or greater or equal or smaller, depending on how they implemented that. But that is a big magic, because I always wondered, how does that even work precisely? And the other thing is, then I was wondering, after reading all the details and thinking about this, I was wondering, how can this be efficient? Because the problem is, it needs to iterate the geometry for each of those tiles again and again. So if you have like 100, or let's say if you have 1,000 triangles, it would need to iterate this over and over again for each of the tiles. And because that surely can't be efficient, right? So the thing is, of course, it needs to pre-sort the geometry into lists for each tile, so that probably in the Dreamcast, in the early PCX 1 and 2, and maybe Kuro also, the host CPU certainly needs to prepare all the lists as seen in the Dreamcast documentation. They have here lists. Actually, I probably should have prepared for that better, but so lists with parameters and like global and local geometry. And because otherwise this wouldn't be efficient, right? So they need to dramatically optimize the geometry lists to only walk the geometry of each tile. Because reiterating, imagine you have there, even if you have only 64, but you have more like hundreds of tiles, you can't walk your whole scene, your whole screen, your whole entire world geometry over and over again. So, because I was thinking this, sure, it sounds always amazing, but how can that be faster? Okay, that is certainly the two tricks. Local level 1 cache like set buffer, and pre-sorted or in probably newer silicon, potentially hardware sorted lists for all the tiles, so that the deferred rendering, and again, even that it's maybe this is actually not as good as people always think, because as far as I see, I probably need to implement this sometime soon. Also, yeah, share, like, and subscribe, and Patreon and stuff if you want to see me writing open source PowerVR code. But to do this efficiently, all the clipping on the tiles, sorting this to the tiles, needs to be very efficient. Plus, if you do GPU, like general purpose computing on the GPU, you don't have any win anymore anyway. I think you do AI stuff, artificial intelligence, neural networks, or other, God forbid, cryptocurrency or so. You hash stuff. There is no deferredness there. You need to, for computational stuff, you need to run all the code anyway. There is not tiling your cryptocurrency or tiling your AI stuff. Your neural network needs to be fully computed. So I actually question a little bit how amazing it really is, given for some workloads it has no benefit, and even for the workloads like games or other normal 3D object scenes, where this deferred rendering can have some benefits. Even then, it's probably really tricky to actually achieve those benefits, given what I said. It needs to iterate all the stuff twice, and you need to carefully sort this in tiles, in per tile vertex lists, for this to actually be efficient. There is one major thing. So actually, I spent quite some time researching and thinking about this. Because I always wondered what happens if your scene is too big to fit into the geometry cache. I think maybe the Dreamcast, but correct me if I'm wrong, maybe the Dreamcast had 512. Probably I should have made a little dedicated list. Maybe that was somewhere visible on this thing. Maybe it had like 512K geometry cache. Actually, maybe we find this anyway faster in the emulator potentially. So, but anyway, correct me if I'm wrong. If you have knowledge in general, if you have knowledge to this stuff, or if you've worked on this and you want to share some details, leave them below. Because surely the geometry needs to be on chip to be fast for this 2-pass deferred rendering to be efficient. And I was always wondering, if the game has too much geometry, how should that work then? Like on an Apple iPhone, which had PowerVR, right? And it turns out, I think the way it works is, you can simply DMA the set buffer to main memory. Of course, that is not efficient anymore. This has, of course, a significant performance penalty. But if you run out of on-chip geometry cache memory, you just render it like immediate mode. The whole stuff is, as I said, it's very similar to immediate mode anyway. The only thing is 2 paths for tiling that and 2 paths for optimizing overdraw a little bit. So you render the tiles, you DMA the on-chip set buffer. You lose the benefit of not having a set buffer because you need to DMA this stuff somewhere where you can save it. And then you render the additional geometry a second pass, the whole frame buffer. Again, of course, highly inefficient. You lose even more benefits. And all in all, I question a little bit how beneficial the whole approach is, because truth be told, PowerVR S5, I've seen neither PCX1, PCX2, Neo 250 or the mobile silicon VR performance rockets to start with winning performance competitions. I think these are all the tricks. That's probably the summary. I really question whether imagination has any chance to come back or ever arrive at high performance desktop and server game. We've seen this so often in IT, vaporware promises and wishful thinking. And even in the mobile space nowadays, because in the mobile space actually a decade ago they have been rather dominant there. Most mobile 3D stuff was PowerVR. A long list, of course, as usual on Wikipedia, and so this was also here somewhere, you see. And this is, you would think PowerVR doesn't even exist unless you know embedded in mobile space, because initial series 1 and 2, NEC, ST Micro, Cairo, and then all this stuff is all mobile, including all the iPhones from probably the very first one. Correct me if I'm wrong, probably the first one, until, I don't know, recently. Just recently, a year or two ago, Apple switched to their own Apple Silicon. And that is said to be also B-tile-based deferred rendering, which most technologies are probably stolen or inspired from Imagination Tech, which I heard is also why they still pay them some hundreds of millions or billions or something in compensations. Yeah, until recently I would say a few cents closing words. I think PowerVR would be significant more successful if they would have had Linux drivers. They had for the Kuro previous video. I made a couple of videos about the Kuro and the Intel GMA 500. Maybe I'd take a closer look at the GMA 500 stuff, the infamous Intel Pulsbo stuff, and which comes with this PowerVR graphic. And this is also in probably, you don't have a Linux driver, you don't win embedded projects already for 15 years. And even in the embedded space with Android smartphones, I would say the lack of proper Linux drivers ever, especially open source ones that you could maintain and not only work with one specific old driver, is also why we had so much innovation in the ARM GPU space, because since the quite monopole situation with PowerVR in mobile, we had ARM, Mali, Vivante, and all the others there, for which we even have open source drivers. So, which is maybe also why, it's probably two things why we don't have open source drivers. Normally, like NVIDIA and so on, people are interested enough to reverse engineer this, like myself here for a decade when I auctioned the first Cairo here just for reverse engineering. It was not a pressing issue for me, right? For NVIDIA, there are people to reverse engineer that. For PowerVR, the performance was always lacking. And by the way, one other fun fact, their driver, they often talk in documentations about some microkernel, which I find a little bit misleading. Maybe what they call driver infrastructure, they have there some microkernel thing. I think what they mean is they have such a big blob that is a little bit more than a driver, maybe with like timer and like scheduling all the geometry sorting or something for the tiles. I don't know, I'm speculating, but maybe that is, they created there such a complex mess that they don't call it driver but microkernel, and because it's a rather big piece of binary blob running next to your operating system, at least that is my impression, correct me again if I'm wrong, again all proprietary closed source stuff. So yeah, maybe this microkernel, this big thing, confused people so much and was so disgusting that those people who tried to reverse engineer this always gave up because it's just such a complex, over-engineered piece of chaos, maybe. At least it's just my impression of that. Yeah, just wanted to share this overview. I hope you learned something. I hope again, as of course I could make these videos even better. Right now I'm obviously not in my office and with some ultra low voltage Microsoft Surface garbage. I hope this video quality is somewhat usable. I could of course make fancy diagrams and stuff, but it just takes too much time, right? This is why I try to build this channel with using some illustrative stuff here from the interwebs and so on, because if I sit here and animate here amazing graphics of tiles and how this is sorted and it's going, basically it's just going. Actually, I think that even the Dreamcast, you could configure that. It was somewhere here in the Dreamcast SDK that here was, stuff's a little bit slow. Dreamcast could configure rendering order, horizontal or vertical, I think. And one last thing, you see how much I looked into this and research, I did some evenings. I think I saw somewhere mentioned that theoretically you could even, if you reach 60 Hertz or near 60 Hertz quite constantly, you could even get away without double buffering, as like reaching 60 Hertz with those slow silicons, like, yeah. But theoretically, because why? Usually with immediate mode rendering, you chaotically render the scene all over the place, in whatever order the game engine obviously delivers your game world and enemies and stuff. And because of this tiling, it goes here through the tiles from left to right and top to bottom. Very theoretically, especially if you hit like your output frequency, you could get away with not double buffering this because you nicely render your whole screen left to right, top to bottom. Not sure how much. It's probably marketing stuff on one slide that has probably zero practical relevance, but just like interesting stuff, as interesting as DMA, the on-chip set buffer out there for larger geometries. Another benefit, just because I just mentioned it, is locality, because this is rendering, so theoretically it benefits of this As I said, you don't need set buffer, you don't have set buffer bandwidth because it's on-chip internal for just this tile. So there is where all the big savings come in here from the set buffer. And also locality, so the cache locality is a little bit higher because again, immediate mode rendering, erratically immediate mode rendering this all over the place. So the cache efficiency is less high, but again, huge drawback. Rendering each tile twice plus efficiently pre-sorting the geometry to per tile geometry lists, otherwise going 100 times over the whole geometry, as I outlined earlier, not very efficient. Let's quickly look at the comments. Just wanted to summarize my findings. And so yeah, welcome everyone. What do you think of Apple M1 chip? Previous videos, but again, if I discuss this, then the videos become too long. I made a dedicated Apple M1 video. Maybe it's probably most efficient if you watch that. Otherwise, I reiterate everything, and people don't watch this video because it's too long, of 20 minutes. Apple M1 reiteration. Whole rights. Been watching for eons. Have you considered getting a better microphone? What do you mean? The amount of reverb? This is only here because this room doesn't have such much interior. In the office, I think it should be pretty amazing. I think usually I think the audio quality is pretty good for this lavalier microphone. Just this room. Actually, if you watch the videos in the office, I think the audio in the office should be quite good. But yeah, keep me. Or actually, I hope I didn't have here some. Yeah, it's just this room. Maybe I need to hang some blankets on the walls or something. Anyway, I hope you learned something. As always, if you have inside knowledge, because ironically, not only, and this is also the irony, right? PowerVR has a Linux driver but doesn't publish it due to intellectual property and trade reasons, whatever. But they lose all the Linux, they lost all the Linux market share, right? They had like once 90% market share. Now they are down to, I don't know, 10 ballpark guesstimates. And if they would have just supplied the Linux embedded people as usual, just being too arrogant, it's like, yeah, Linux, nobody's using that. And then Android and Apple, of course, copying that and using their own silicon. Now they are back where they are. I would say they are back where they are 25 years ago, sorta. So that is certainly interesting to see where that is going. And on top of the driver that PowerVR, like Imagination Tech, has, but never published in source and only published through vendors in really crappy binary only blob form, Intel has contracted two drivers with two different companies. So Intel had, for the Intel GMA 500 and stuff, Pulsepore and stuff, they had two drivers that both were not the most amazing and both not open source. And this is really crazy how even Intel, as such a market leader at the time, could not negotiate terms with Imagination Tech. Also, I find this really crazy from Intel to have Intel CPUs out there where they have so little rights and leverage to publish, even if they paid external companies to publish this open source code for the drivers. That is really mind-blowing. I don't know what is the story. If you have other inside knowledge, as usually in the comments below. I wonder why Intel had contracted two drivers. Maybe they tried with convincing Imagination Tech to have those drivers published, and this is why they tried twice with different people, and in the end maybe Imagination Tech both times vetoed publication of those drivers. I don't know. Crazy stories. I hope you learned something. That's it for this video. It's too much reverb here anyway. So see you soon for that. And don't forget to like and subscribe for all the next details videos. And maybe I make a questionnaire if I should even spend. And for me, this is just being curious about technology. It doesn't even make the most, it certainly makes zero economical sense to spend my time, which is also why I've not done this the last 10 years, to reverse these drivers. It's mostly for this YouTube and Patreon sponsorship and spreading knowledge here. And of course I have a few boards. I have the Cairo 2 or Kuro 2, names, how to pronounce them. Intel GMA 500 twice, plus an ARM and a NIPS board. So theoretically, yeah, but of course I don't use these boards daily. It's just a historical thing of, hey, wouldn't it be cool to have those drivers? So yeah, hope to see you next time for all this fun to come.